Attach to function test of CSV table. Previous lectures we talking about loading CMS CAPP's CSV file and display the robots on the screen. The CSV file with three parts. The first part is X file, that is the scene itself. The 3D model will display on the screen as all the X file of J1 to J6, as well as the tool will display on the screen. The second part is the attach to that column. Attach to with three values. 0 is for foundation, fixed parts. Attach to if equal to 1, that means that the object is moving translation along one straight direction, moving. Attach to value if being 2 means that the join is a rotating object which will rotating around a pivot point and along a vector direction. The third part is the relationship between virtual machine and the fixed machine. Actually, is the definition of the motion control axis. Today we are talking about attach to. It's the mechanism, the structure of the geometry model. We open RPG2 first. Open RPG2 from C drive's RPG demo folder and RPG2 file. Open DSW, the program on the screen. Let's see if it is the original program. We test the FNAC 710, so we test the scene input FN 710 new. Okay, the model is correct. All the X file, all the scene of FNAC 710 display on the screen is correct. The program RPG2 is original one. So we continue to next lecture. We mark F2 here first, and then let's go to begin scenes. After show animation, show floor, this program is showing the robots. You can see robot 2400, the join equal to 2, initial a matrix, update the matrix, update type 1. Update type 1 is doing translation, move back to original position, and then rotating about R2A. Join 2 is R2A, and move back to its original position, and update. The most important is update type 3, output the matrix. Output the matrix for what? For render in here. As render, that join will position at the right pose. So the I value varied from 0 until 6 until the tool displayed, then the robots displayed on the screen. The attach tool simply to test the parent and the children's relationship. Suppose we rotate J1 a degree of rotating, then J2, J3, J4, the rest will be influenced, while the foundation still stay there, because the foundation is the parent of the J1. The children will follow, but the parent will not. So we'll correct this function to execute the attachment attached to functions testing. The easy way is to copy, transrotate 1, transrotate 2, rotating from CMS CAPP. It is the fastest way. Okay. But CMS CAPP is for station 9. In RPG2 is only 1 station. So we have to alter something. Okay, let's open workspace from D drive, CMS GAC, open a Chinese version, CAPP CH CMS, and open .dsw. Okay, the program at the right half screen, and RPG2 at the left half. For every join, the join from 0, play F is 0 until the M known. M known is including the tool. 6 join including the foundation 7 and the tool 8. For each joint we have to do operation. As I remember, it is by this routine, transrotate operation. We copy these routines to move to here. Control F2 first, and just in front of frame. And go to the top of the routine and mark Control F2. Okay, first of all, in RPG2 is only one station. So the argument for multi stations, we have to cancel one argument. And lease for multi stations, we have to remove it. For whole routines, the better to use replace all. Find what? Find at least one. P9 STY minus 1. P9 STY minus 1. Replace with nothing, just delete it. Replace all. Okay, this is for first replacement. The second one, is this one, P9 ST minus 1. Remove it. Replace all. P9 ST minus 1. Replace by nothing. Replace all. Okay. The long objects, we have to replace to character object without X. So replace long objects, replaced with character. Object without X. Replace all. Okay, it seems alright already. And we handle only translocate 1, 2. So the 13 for conveyors, my suggestion is don't let the program too complicated. So we remove the conveyor parts of the instructions. So we handle translocate equal to 1 and translocate equal to 2. The translocate equal to 12, remove it until the end. Okay, let's see what else. Okay, it seems okay. Then, where to put this routine? Just for every J1 to J6, we pass to here. The routine coding, we don't need this one, just translocate operation, and without integer announcements, the I, only I, not IKY. That's it. So as I equal to 0, then the routine argument 0 and out. If I equal to 1, then here is 1. So 1, 2, 3, 4, 5, 6, 7 until the end of the tour is the last one. The matrix operation, just like this. Okay, and one more. For every J1 to J6, we defined as current position X, Y, Z. It's better to copy from CMS CAPP current position X, 6 coordinates. We simply put at the rear of the variable group here. Only one station, so this array 9 has to be removed. SYZ UVW is ITRI's definition. Simply is 1, 2, 3, 4, 6. So this is the end. The AB know these joints. Okay, then better to finish everything. We don't have any function to adjust 1 to 6 joints value. The only thing we can do is by means of the programs change the value of this variable. So we just define, suppose the first join is 0 as stated, locate there, and the second join at the beginning is 0 as well. The third join 3 is 0 as well. For this 6 notation is degree, 0 degree at the original. So the FANUC 710 at the beginning will display at the home position 6 join coordinate all equal to 0. Then we will test if the first join rotate something, the rest objects will be influenced according to the J1's matrix. The rest object will follow the same rotating angle. If true, then the program is correct. The attach to function is correct. Okay, let's compile to debug. (102) errors. Control F. Input error to see what else. Okay. This routine is a member of Wingman. You can see CAPP transrotate in front. So we have to add into Wingman header in private. The member in here don't need to add these characters, only this transrotate operate. Okay, let's compile. Zero error. Then let's go. As we calling sync input to adopt FNAC 710 CSV, the every join is 0, so the pause just like this is okay. Then let's change something. Suppose we test the first join first. Suppose we rotate 90 degrees, the J1 rotating 90 degrees, to see what the pose is. As we know, the inside is coordinate system is left hand coordinate system, now the right hand coordinate system. So as FNAC 710 CSV table be opened, correct. Why is correct? We're rotating the first joint 90 degrees. How to say it is correct? The first joint rotating around 001. The vertex, the vector in is to point to the sky. So we put the left hand, the thumb of the left hand pointing to the sky. The four fingers curved is the rotating direction, 90 degrees, turning from here 90 degrees to here. So everything is perfect. The J1 rotate, the J2, J3, J4, the rest, including the tool, will follow the inference of the matrix. This is what we want to test. The attachment, the mechanism, the structure of the geometry model. So the first join evaluate okay. Then suppose we turn the second J2, suppose 30 degrees. And then let's check the pose and to see the parent and the children's relationship is okay or not. We forget the flower first. Let's see the pose first. So the J1 rotating 90 degrees to this direction. the J2 rotating 30 degrees. It is correct. It turned this direction. So the robot's pose is okay, but influenced the floor. The floor is joined by vertex baffle. Previous lectures we're talking about the animation will influence the floor. We use org.x, a dummy dot at the original positions. No one will notice which is existing. Use these methods to cut the influence of previous matrix to the floor vertex baffle. In here, seems we have to try these methods. Otherwise, whoever want to clarify the inside matrix operating procedures, investigate the error, they have to take times to handle this trifle problem. We just use a simple way, adding one org.x objects at the real of the mechanism of robot to cut the influence of robot to the rest vertex baffle. Okay, let's do it. First of all, we find where is org.x. Okay, here it is. Let's see first the 15 units, the mesh created. Then animation load, say loop, object create. After this bracket, the I increasing 1. So in here, I is 16. And adding object mesh will be loaded. The X file is org.x. And then object 16 create. So these two lines is what we want to put at the real of robot. Robot scene. Where is robot scene? Loading. The robot scene loading at the load scene. This routine. Load scene. This routine's 3 parts. The first part to create the 0 to long for 710 Fanaka is 8. To create the mesh first. And then this for loop is to create the objects next. This one to handle attach to. So the easy way is to put these two lines at the real of mesh. But don't forget, we are not animations anymore. We simply is objects. As this finished, the IC LC will increase in 1. So in here is IC LC the mesh will create according to org.x, and then create the objects according to the character mesh. That's it. As we add one, then as rendering, we have to render one more. Where to render? To add this one more object rendering is begin scene. Okay, animation first, the flower next. Here, after number looms rendering here, then we render one more. The eye after the bracket increasing one already, so we simply copy this to add a real. Render one more. That's it. This one will cut the influence of robust matrix. So let's compile to see the flower problem will solved or not. Let's go. Let's use C input to adopt FNAC 710 CSV file. One more. Right? So the first join 90 degrees. The second one 30 degrees. The flower still locate at its original positions. The previous influenced by the matrix of robust. This problem solved. Okay, let's continue. Next one. Let's join. How about to change the join 3? The second rotating 30 degrees. The third still rotating about y-axis. Let's rotate the third joint minus 30. So the rest still keep horizontal. Let's see if it is true or not. Let's go. Scene input FNAC 710. Okay. First join 90 degrees. Second one 30 degrees to this direction. The third rotating minus 30 degrees. So this one is horizontal. Is correct. So the join 4 90 degrees. The parent-children's relationship seems okay. The children move, the parent never moving, don't have relationship, have no influence by the children's matrix operation. The parent's matrix operation will influence to the children. Okay, 90 degrees rotating around x-axis 100 direction. It is correct. So how about the next one? we turn the fifth joint 90 degrees. The next one is rotating about y-axis. Let's go. Scene input. FNAC 710 CSV. Again, you see, rotating 90 degrees. And have a look about the tool direction. Next, we want to do rotating the last joint 90 degrees. See the pose first. Then the sixth joint will rotating 90 degrees as well, which has only influenced the pose of the tool. If it is okay, then attach tool function testing finished. Okay, let's go. And your scene input. FNAC 710. You see, the tool influenced, turning 90 degrees. So we know the attached tool functions testing alright. We will porting on our company's website RPG tool. Actually, the whole RPG demo update to this version. Someone interesting about RPG tool can download and developing their own app program. Okay, ending.
Shanghai